As we move on in chapter 6, we're done now of using different ways to solve for systems. There is another way that we won't talk about until you're in Algebra 2, but so far let's review. In 6.1, you guys learned how to solve using graphing and tables. Let's write that down. 6.1, you were able to solve using graphing, and you were able to solve using tables. The benefit to this is that it's a nice visual, but the disadvantage is if the numbers are really big or if the numbers are decimals or fractions, you're not going to have an accurate answer. We moved on to 6.2, and that was substitution. Now in substitution, you guys kind of like substitution, but at the same time I gave you very challenging problems that you would never be able to do in 6.1. So it's not maybe that you didn't like substitution, but substitution allows us to do the more difficult problems. In 6.3, we moved on and we used the concept of elimination. Again, you guys seem to kind of like this one, but I didn't give you I didn't spell that right. There you go. I didn't give you extremely difficult problems, again, in 6.3, so you probably liked elimination more than substitution, but both substitution and elimination are your best methods of solving. We can do the solve it together when we come back together in class. Today you're going to be presented with word problems, and you're either going to graph them, you're either going to use substitution, or you will use elimination to solve for the word problems. So it's good. Today's almost a nice little review for you. Okay? Now you got to pick which one you want to use and when you want to use it. So graphing you can use when you want a visual display, or if you want to estimate a solution, because you can't get an exact answer all the time. Substitution should be used when one equation is already solved for one of the variables, or when it's super easy to solve for one of the variables. And then elimination should be used when the coefficients of one of the variables is the same or the opposite, or if they're already lined up, and then elimination would be beneficial. Okay, let's try this and see what you want to pick. Now you're going to have different types of problems today and tomorrow. We're going to take 2 days to apply what we've learned in 6.1 through 6.3. So we're actually going to be on 6.4 for 2 days, and then you're going to have a quiz on 6.1 through 6.4. So the next problem talks about breaking even. Breaking even is when your income, and I think I had another word there, but we really don't need it. It's when your income equals the expenses that it takes for you to get to what you need to have. So as a visual, you can see you can have an expense chart, and then you can have an income graph, and where they meet, that's what you call the break-even point. If you ever open a business someday, you'll be in debt at first, but then as you continue to sell or produce or whatever you're doing, you're going to reach that break-even point, okay? So let's look at problem 1. A fashion designer makes and sells hats. The material for each hat is $5.50. The hat will sell for $12.50. I'm going to zoom in a little bit. It's kind of hard to read, I know. Now the designer spends $1,400 on advertising. How many hats must the designer sell in order to break even? So what we kind of want to do is talk about the different costs, okay, or the expenses, excuse me. The costs to this designer is $5.50, right? And that is for every hat. So we're going to multiply it times H because it's for every single hat. The other cost is the spending for advertising. Now, it's just a flat $1,400, okay? So your cost is made up of $5.50 for every hat and $1,400 for the advertising. Now, how much does this designer make? How much do they sell them for? They sell them for $12.50, which means that's how much they're making them for, okay? If you would rather put income here, you can do that. Now, she's not going to make $12.50, she's going to make $12.50 times every hat, so we have to put the H on there. So what we want to do is see when the two of these equal each other. So the cost, $5.50H plus $1,400, when is that going to equal her income? And if you want to change this word selling to income, it might make it easier for you to understand. Okay? Now we're just going to solve this like a basic Algebra 1 equation. Take away $5.50 from both sides. And honestly, guys, I might be teaching you this different than the book, but I hope how I'm teaching you this makes sense. You get down your 1400, and 1250 minus 550 becomes 7H. When you divide each side by 7, you will see that she has to sell 200 hats to break even. And there is your answer to your equation. Now, you don't probably even know that it happened, but you actually did solve for y. Or excuse me, you did actually use substitution. I'm not going to get into it because I actually don't want to confuse you more. If you feel like you got that, there's no need to confuse you. So we have again a profit equation type idea, an income and a cost. This puzzle expert is making a Sudoku puzzle. Here's his initial cost, $8.64. And then on top of that, binding and packaging costs 80 cents for every book. The price, though, that he sells them for is $2. How many copies does he need to sell in order to break even? So it's helpful to list your costs. And the cost was a flat $8.64, they stated, for whatever. They aren't telling us, but it's $8.64. And it also costs 80 cents for every book because they need binding and packaging. I'm going to use the letter B for that. You don't have to. You can use X. Now the income, right? The income is $2 for every book. So that needs a variable. So we simply need to figure out when is the cost, $8.64 plus 80B, when is that going to equal the income? Take away 0.80B. We have a basic Algebra 1 equation. 864 equals 1.20b. And when you divide by 1.20, you will figure out that he needs to sell 720 books to break even. Oh, you can't see that. There you go. Sorry. And that's how you do break even problems. Let's move on to a different type of problem. And we're going to talk about constraints and see if some things even exist or if we can solve a problem, because sometimes they don't give you enough information. Let's read this paragraph together. In a real-world situation, you definitely need to consider the constraints. Now, constraints are like things that are working against you, things that won't ever happen, described in the problem in order to write the equations. Once you solve an equation, you should definitely consider the viability of the solution. For example, a solution that has a negative number of hours is definitely not a viable solution. Okay? As we go on to problem 2, we're going to see when, if this might happen. So let's read problem 2. The local zoo is filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water, and it's filled at a constant rate of 10 gallons every hour. The second water tank already has 29 gallons of water in it, and it's filled at a constant rate of 3 gallons an hour. When will the 2 tanks have the same amount? Explain. Well, let's make some 2 equations. Let's talk about tank number 1 and then tank number 2, okay? Tank number 1, it starts with 50 gallons, okay? We know that. And it fills up at 10 gallons every hour. So we can just put an X behind this, and X can represent the number of hours. We can make that say equals Y if you don't mind. And that could just be how many gallons there will be. Should we label that? X is the number of hours, and Y is the number of gallons. Okay, at least how we wrote it. Let's go ahead and continue on to the second tank. The second tank has 29 gallons in it, and it's filling at a rate of 3 gallons every hour. And then that will equal Y, how many gallons we'll end up with. Well, if you guys don't mind, we can do linear combination or substitution. It really doesn't matter. I find this problem to work very well with substitution if I box in the 50 and the 10 and I replace it in this equation. So my goal is to get 29.3x, which is the second tank, I want to know when that equals 50 plus 10x. That's the first tank. Let's get the x's on the right-hand side. So 29 equals 50 plus 7x, because I subtracted 3 from both sides. Now let's take 50 over. Now unfortunately, when we take this 50 over, we get a negative 31 equals 7x. And if we divide by 7, we're going to get a negative. And I guess I'll give you a decimal on this, and we'll talk about what this means as the negative. It's like negative 4.4. Okay, and then that goes on and on and on and on. Hours. And that equals x. So in other words, I'm sorry, when you divide, you don't get 31. Sorry guys, you don't get 31, you get 21. Don't worry, your math teacher can do math. I'm sorry. You don't get 31, you get 21. When you divide, you get negative 3 hours. Still, the idea is that we have a negative hour, right? You can't go back in time, as much as sometimes we all wish we could to do things differently. You can't have a negative hour because you can't go back in time. Now what does this mean? This means they will never be the same. Okay? This is a constraint. Now you might have already kind of understood that, because the first tank started really high and it was going very fast, and the second tank started very low and it went pretty slow. Oh, that rhymed. Okay, so if that happens, if you have one that's already very full and then you go really fast, I hope it makes sense that the small one, if it doesn't go faster, it will never catch it. Okay, so these are never going to be the same. Now if you're really wondering what this negative 3 means, that means that 3 hours in the past, like if it was, 9 o'clock at night, that means at 6 o'clock at night, 3 hours ago, they could have possibly been the same amount. But it's not happening in the future. Let's try this again. We have 2 more water tanks, yay. We have 10 gallons of water, and it is leaking at a constant rate of 2 gallons an hour. Okay, so tank number 1, we start at 10. Now I hope you know that since it's leaking, we're going to have to minus 2x, okay? And that is going to equal our tank 1. Tank 2, let's read about it. The second tank has 6 gallons, and it is leaking at 4 gallons an hour. When are they going to be the same? Well, let's take 10 minus 2x, sub it in, and we get 6 minus 4x equals 10 minus 2x. And maybe you already know what's going to happen, guys. Let's check it out. I'm going to take the 4x to the right because that's going to make it positive 2x on this side, along with the 10. I'm going to take the 10 over and I get negative 4 equals 2x. Divide and x equals negative 2 hours. Again, we can't, sorry, I know you can't see that. Here it goes. We can't go back in the past. So these are never ever going to have the same amount of water. So we can say they will never have the same amount of water. So just think about your answers when you write them down. If the answers don't make sense, it's possible that there might not be a solution. Let's go on to the next problem.